He seemed very confused, oh, okay.
Yeah, bless you.
It's the only time I get to yell at him without his girlfriend yelling at me.
Nice.
There you go. Well, get a new bike. Yeah, you're gonna let me trade it in for a 2025 Kawasaki K exclusive.
So on Thursday, the 18th, we already had one recording, one lecture. You did 4 examples in your notes. This will be the continuation. So if you were gone Thursday, I have to assume that by now you've done your due diligence and watched the video and that you're up to speed with everybody else and you know the gist of this. So we're going to solve this. And then, of course, we're going to graph it.
Well,
Let's get to it. So treating this just like an equation, what would we do first? Yep. And again, your answer will eventually evolve out of that, but that is the exact perfect answer for where we're at right now, and that is to subtract 4. And most of us are done falling for this trick right here. Remember that minus doesn't belong to the 4, it belongs to the x. So whoever said subtract 4, thank you. You're exactly right. That is a positive 4, and we eliminate it with a subtraction by 4. So we're going to copy that or cross that out. We're going to bring down the negative. It used to be called a minus, but now it's called a negative x. Is still less than, and what's 7 minus 4? 3. So with equations, this step generally was pretty relaxing. With inequalities, it's a little bit less relaxing because we got to kind of step up our game a bit. What are we going to divide by? Negative. Some people say negative. Some people say -1. At the end of the day, it doesn't matter because what's going to happen is going to happen. So I'm going to divide by a negative here. And again, if you feel anxiety from that, then put a 1 there. It's all the same. And with equations, this was not a thing. But what did we learn on Thursday is about to happen? Yeah, Jojo? Right. And we learned that on Thursday that good job, that when we multiply or divide by a negative number, we have to take our Pac-Man and reverse it, right? So instead of Waka Waka to the east, now he Waka Waka's back to the west. And then the math is 3 divided by -1 is -3. Okay. And we like this answer okay because the variable's on the correct side, the left side. And so now we would proceed to make a graph. And so you would just sketch a quick number line. And we just make sure we only have one number that I'm worried about, and that's the boundary. So -3 should go in the center. Don't worry about where 0's at. I know that that's a thing for some of you, but I'm not worried about that. I just need the boundary. And what kind of circle will I put? Leave it open, correct, because we don't want people to think that -3 counts, right? -3 isn't greater than -3. The absence of the or equal to tells us to leave it open. And which way will we shade? To the right, because this says is greater than. And numbers get greater when we go to the right on a number line. So we're going to shade the right side and then put an arrowhead on it like this. What's up, Rowdy?
What changes the fill in the circle or like leave the circle blank?
If it has an or equal to with it.
If it's got that sign with a line under it.
If you think about this, if I added or equal to this, then it would become true now that -3 is greater than or equal to himself, right? So the or equal to would allow me to color the circle in because now the graph says that -3 is like it counts, right? But in the absence of that, we leave it open to tell people that -3 is actually not an answer. It's just right on the boundary of being an answer. Okay. You're fine. What's up? Yes, inequalities generally will have infinitely many answers. Yes, which is why we don't want to just leave it at saying the answer is this. We like to illustrate it on a number line since it's like with equations, it doesn't really maybe it makes sense, but it doesn't really help to just make a number line and like put a dot. Like who cares, right? But with inequalities, we like to see that set. We want to see where it starts and where it goes. Yeah. Let's do 2 more examples. We got 4 of the 7 done Thursday. So here's our next one. You have to stop that.
Okay.
But again, we're not worried right now we're not scared or anything like that because we know that all of our training with equations will guide the way right there. We got to worry at the end about nuancy little things like switching signs and getting X on the correct side. But initially, it's just autopilot cruise control. What do we do first? Distribute always is going to be the right answer. If there's parentheses, let's distribute them away. So we're going to take the -3 on the left and multiply it through. And what do we should be past the point of getting these wrong, but let's make sure. What do we get? We get -6. No need to be sorry. What's next? Plus 3 times X. Good job. Remember to switch that minus to a plus because the distributor, that leech on the side of the parentheses, is a negative. He'll switch everybody's signs out. You do not change your inequality sign yet because you did not multiply this entire problem by a negative, okay? That multiplication, I get this question sometimes. Some people say, well, you multiplied by a negative. It's like, well, that was local. Like I just did it on the left side, right? It doesn't really count. And let's head to the right side. What do we get?
6x.
6x minus 18. Yeah, we don't change that sign because our distributor was not a negative. It was just a boring old +6. So at this point, you know what I'm going to find is over the next week, we're going to see a split. I'm going to see a split. About half of you are going to join the following team. Team, always get the variable on the left. About half of you are going to join the team called keep the X positive regardless of which way it goes. And only you will decide that. And I don't care. I couldn't care less which side you pick. I stated my case on Thursday, how I feel about this. I like to get my variable on the correct side right now while I have a chance. So contrary to something that I told you a few weeks ago or a couple of weeks ago, I am not going to kill the smaller X. I'm not going to pay that any mind. I'm going to subtract 6X from both sides. That is my prerogative. Okay. And again, I'm not scared of a negative. I'm not scared of having to divide by a negative. I'm not scared that I'll forget to change the Pac-Man backwards. So I always just get my X where I know he's going to want to be anyways. So I'm going to cancel these out and I'm going to copy down my new problem. Every time you do a step, you make a new math problem. With equations, inequalities, that's what you're doing, is you're always just writing new problems. So my new math problem says -6 minus 3x's is still greater than or equal to -18. And I took control of the situation and I planted my X on the left. So that will be one less thing for me to worry about later. What's the next step? 100% add 6 to both sides. That straggler term has got to get away from my X. And my new math problem says -3x is at least, what's -18 plus 6? -12. And listen, I have faith, especially having watched you guys work now for the last month, that you can handle this, right? 100% of you are going to remember that we have to divide both sides by a negative, and 100% of you are going to remember that because we divided both sides by said negative, we are going to flip our Pac-Man. So X is less than or equal to what? 4. So on this one, we're going to make a number line. We're going to mark it, notch it with a 4. And this time, Rowdy, we are going to make a circle, but we are going to color it in because we want the reader of our graph to see that 4 counts. 4 is less than or equal to himself. And which way will we shade? Left. Always base your shading direction decision on your final answer, right? Because if you'd looked earlier in the problem, these both would have been greater than signs, and I'm going to go to the right. Base your answer on your final answer. Base your graph on your final answer, okay? That leaves us with just one more example. So this one is 4 times the quantity x minus 9, close quantity minus 3 is less than the opposite of the quantity 2x minus 6 closed quantity plus x. I just asked this question because I need to make sure there never comes a day when you answer it incorrectly. What do we have to do first? Distribute. It's always going to be the answer. Nice job. So for this first set here where I'm drawing these little white arrows, what do we get?
4x and
It's going to stay as a minus. Let's get that down first. 4 times 9 is
89.
36. And then we copy down the -3. We copy down our less than sign. And now over here, I'm going to change colors because this is where we got to step up our game. Any algebra teacher will tell you this is the death zone here. It's definitely going to be -2x. And it's going to change to +6. And that right there, those of us like Mr. Manlove and me, us old guys that have done this forever, will tell you this is where the grades fall. A negative distributor will change things to what they used to not be. That's what they do. So -6 has a new identity. His new name is +6. And then we'll copy down the +x at the back. So I color-coded there for you the death zone. Please try to work that out of your system. Negative distribution is a sign switcher. What do we do now? Combine like terms is generally going to be the second right answer. Nice job. So on the left-hand side over here, I'm going to put some like terms together. What am I going to get?
Combine 36.
Yeah, so -36 with -3 more makes -39. If you already owe someone $36 and you borrow 3 more, that's what that is in a real world illustration. You now owe them 39. Keep the sign the same. On the right-hand side, my like terms are not numbers this time, they're variable terms. So, and what do you get when you take -2x and add 1x? You get -1x. -2 plus 1 is still negative, of course, but it's only -1. And then I copy down the +6. Anything that didn't get used, you just copy down.
And then wouldn't you want to eliminate the negative x?
I would. And again, if you were to ask me, why am I going to do this? I'm going to write it in purple. Why, Mr. Ahern, did you add x? My answer is not going to be because it's smaller. My answer is going to be because I want to push all my x's to the left. Negative, positive, don't care. We're past that. I am.
So then you'll get
So on my left, what do I get? Good
Okay.
job, Seth. I get 5x.
is less than or less than 6.
Good job. And the stage is set, right? We've constructed this. We've controlled this problem. We've built it right to our liking, and then we're home free. What do we do now? Add 39. Any other answer than that, and I have failed you in these last 5 weeks. 5x is less than, what's 6 plus 39? 45. Last step.
Divide.
We're going to switch our Pac-Man?
Yes.
We are not, because we did not divide by a negative. Had that number right there been a negative, then we would switch. But that's all that matters. If he's not, then everything stays the same. So x is still less than what? 9. So again, we're going to sketch a number line. Just place a tick in the middle. Mark it as a 9.
And we're not coloring.
And we are not coloring it in. I agree with that for sure.
And then we're going to the right.
And we're going to the left because this reads x is smaller than 9. Less than is smaller, and smallerness occurs. Is that a word, smallerness?
No.
It should be. Smallerness occurs to the west, to the left. So we're going to shade the less than side.
Smallest.
And remember to put a big old chunker arrowhead on there. Make sure it's clear that your line goes forever, your shading. It shouldn't just peter out. I've seen people do graphs like this, and that's pretty half-hearted. Like, come on, finish the job.
Sure.
Yes, you want to know why I didn't switch the sign? It's because the green number is not negative. So the number when you divide right here, if that divisor is a negative, that's when you switch. Nope. No, division doesn't always switch. And by the way, one last thing I want to say before I pause my recording is just I want to get a misconception out of the way. Let's say I had like 3x is greater than negative 21. Let's say you got to the end of a problem and you're just about ready to go in for the final shot. And what are we going to divide by?
30.
3. Will I switch my Pac-Man here? No. And I just want to get this out of the way because sometimes people hear things, and I'm not naive enough to think that everybody hears every word I say. Sometimes people hear the word, bless you, they hear division, they hear negative, and they hear switch. They go, oh, but there's a negative. And understand that the only time we would switch our sign is if the red number had been a negative. So it doesn't matter that the top number, the dividend, is a negative. We don't care. Okay, so it's still x is greater than negative 7. Only switch the sign if the divider or the multiplier is the negative himself. Yes, sir.
Then why did we switch it on, not the last one, but the one before that?
Because we divided by negative 3. That number I just circled is a negative 3.
Oh, I didn't have negatives. Cause I did it on the other side.
Okay.
Yeah.
I'm going to do this problem again. And I think that, Rowdy, if you could really listen carefully, what you did is a very interesting thing. Let's go back and start this problem over on the other side of this curtain. This is a very worthwhile conversation for your grade. So I'm going to assume that Rowdy and I parted ways right at the beginning, that when I am Rowdy, it looks like he has joined team kill the smaller x. So that's fine. So when I said, heck with it, I'm moving my x's to the left, Rowdy said, no, I'm going to subtract 3x from both sides because I want the smaller one to go away. Am I doing okay?
Yeah.
Okay. So what Rowdy has done is he's solved one problem in that he has kept his x with a positive 3, right?
Yeah.
But what problem has Rowdy caused himself? He placed, bless you, he placed his X onto the wrong side, so to speak. And so let's finish this process with Rowdy so we can all take a look at like how everything comes out in the wash. It's always going to work no matter which path you go down, provided you don't make any mistakes. So Rowdy now has no choice but to add 18 to both sides. Everybody agree? This is a very great question, by the way. I'm really glad that we're having the chance to talk about this. So his 3x comes down. His Pac-Man is still opening to the west. Negative 6 plus 18 is 12. Am I doing okay, Rowdy? Now, when we divide at the end by 3, do we switch the sign? No.
Yeah.
No, because I'm dividing by a positive purple number. So I leave my X right here. I leave my Pac-Man facing here, and 12 divided by 3 is 4. Now, you'll remember on Thursday, your math teacher, that Ahern guy, you know that guy, how he told you that you should always swap so your variable goes on the left. Take, please, somebody, what's in the purple box and read it backwards. What does it say?
X is greater than.
It does not say greater than if you read it in this direction. It says X is less than or equal to 4. So you switching the sign where this little red arrow is not switching because you divided by a negative. It's switching because you knew you had to get the X onto the correct side.
Yeah, this is gonna be a long video.
It won't be if you just do what I said and put your X's on the left. If you will just get over. What's that?
Okay.
You
Does it
put,
always need to be on the left?
yes. At the end of
Oh,
the
yeah.
your answer, your X always needs to go on the left. And if you choose to put it on the right in step 1, well, then you've just created your own issues. So if you have a choice, which you almost always will, put your variable on the left, do it right away, and then you're in control and you never have to worry about it again. Half the time you'll have to switch the sign at the end because you'll have to divide by a negative. You know, that's just part of the deal. Yeah, Joe.
Would you like mark points off if we put it other one?
Let me say this. If you poo-poo my directives and you leave your answer like this, what I just circled in green, does everybody see that?
Yeah.
And you graph it, like this, you have my blessing. I will forgive you. I will look the other way and I will say, this is a this is a kid that clearly understands that what's in the green egg says X is less than 4 or equal to whatever. Are we clear? You will have my blessing. If, however, you have the nerve to leave your answer like the green egg and graph it like this, and then when I ask you why, you have the gall, the nerve, the stones to tell me it's because, well, duh, it's because that says greater than. I'm gonna take off 681,429.6 repeating points from your grade. Is that clear? I might even round that a little bit to negative 681,430, because who needs odd numbers, right? Listen, every bit of advice I give you is honed from 30 years of watching kids make predictable and avoidable mistakes. So when I tell you to put your X on the left, I'm not doing it because I like to put you under my thumb and control your behavior. I'm doing it because I care about you. And I know that if you listen, you can avoid that. That is the most offensive graph answer combination. You might as well just come over to my house and kick my dog and then leave a steaming bag of poo on my porch, because I would find that less offensive than that graph answer combination. Are we clear?
So this right, what you're saying is that's an easy way to get an
Instant. So I know that there's probably going to be like 6 people who just heard the following. Oh, challenge accepted. That's fine. If your graph matches your answer,
Don't kick a poor little puppy. Or I'll
if your
kick you.
graph
Yeah.
matches your answer, we're good. I'm just telling you, please, you should trust me. Putting the X on the left will help you immensely. Got it?
I think 90% of us trust you.
It is time to work on assignment 8. Let's do at least a couple together here just to make sure we're all kind of getting off on the right foot here. So problem number 1 says that R, when you divide it by 3, has got to remain at least negative 20. So algebra just never changes, right? The rules don't ever change. No matter what class you ever get to, algebra is what it is. What do we do to both sides? Should my red flag go up when I say that? Should I be thinking about switching the Pac-Man? No. The only reason I would have to change my inequality sign would be if that red number were a negative. Okay? The negative on the 20 is irrelevant. It's the worker. If the worker number is negative, then you red flag it. So we're going to cancel out these 3s. We're going to bring down the R. We're going to keep this as an at least sign. And then we have to, as always, do basic math. What's a negative 20 times a positive 3? It is negative and it is 60. The only reason you would have to change the sign at this point would be if the problem somehow wound up backwards with the R on the wrong side. But the R is on the left. We multiplied by a positive. Good to go. Box that sucker up. It's done.
That's it.
Stick a fork in it. It's done. Now, by that's it, don't forget we also have to graph it. So just real quick, sketch a little short number line. Put one number on it. That's all we need, and that is the boundary negative 60. Will it be open or closed? Closed because of the or equal to clause in the contract.
Oh, yeah.
If it says or equal to, we color in our circles. And which way will we shade? To the right. So that completes problem number 1. Let's take a look at problem number 2. Problem number 2 on your worksheet says that negative 15, when decreased by X, must remain at least negative 31.
You confuse me when you say that.
I'm trying to use different words so that when we do word problems, you'll be more comfortable with them. Sorry. What do we do first? Add 15, right? So we bring down this green arrow, I want you to know this is the artist formerly known as Minus. He's changed his professional name from minus to negative, right? So you understand that the verbiage of this, that when you read the top line, it says -15 minus X, but the verb becomes an adjective. So now we don't read it as minus X, we read it as negative X. Do we switch the Pac-Man? Not yet. I mean, we will, I think, in a bit because we kind of see what's coming down the pike here. But when you add or subtract, you're not going to switch the sign. There's no reason for that. So it's still greater than or equal to, and math. What's -31 plus 15?
Negative.
-16. Still negative for sure. But it's less negative. You owe less money now. What do we do at this point?
Or is it?
Right. And this time I'll put the 1. Last time I didn't. So in fairness to those of you that like the 1s, I'll put a 1 right here. Follow the purple if you like that thing. And then maybe that helps you to see that we're dividing by a number and not just a sign. So when we divide by -1, we're left with X, mission accomplished. Do we switch the Pac-Man? Now we do, because the purple number is negative. When the divider, the worker, is the negative, then we switch the Pac-Man like this. You'll never get away from basics. It is +16 because it's a negative divided by a negative, and that is the final answer. X is less than or equal to, or if you want to be fancy, you can say X is no more than 16. And so to graph it, you're going to make a number line.
There's a lot of signs to remember.
This one will be closed because, again, we have the or equal to sign in the contract. In fact, you won't see, when's your first problem where you'll do an open circle? 5. 5 is your first open. 1, 2, 3, and 4 all have the or equal to. They'll all be colored in circles. So I'm going to put a circle on the number line at 16. I'm going to color it in to show my reader that I mean business at that point. Which way will I shade?
What?
Left is where the less thans go. So we'll shade left.
Just guessing.
You've known about number lines for a lot of years, and you know that numbers get less than as you travel to the left and greater than as you travel to the right. So just follow that understanding. Does that help a little bit? I'd like to do 2 more. Are you okay with that? 2 more problems, or do you want me to shut up? I don't care. Like, I'm not. I wanted to get to 4, and I thought, well, why skip 3? That would just be awkward. So yeah, let's do number 3 real quick. What's step 1? Adding 15, because we have a negative right there. And the way to get rid of a negative straggler is to add. So adding 15 will make the -15 go bye-bye. These 15s are going to cancel each other out. And this, the artist formerly known as Minus, comes down as a negative. We rename him when there's no longer anything to his left. So we have -B. Do we switch the Pac-Man?
No.
No, not yet. And what's -6 plus 15?
9.
+9. Variable's on the correct side, but we're not done. What do we have to do? Divide by that negative. Again, you can call it a negative. You can call it a -1. I couldn't care less, provided that you know what you're doing. And then when those negatives cancel out, we're left with B. Do we switch the Pac-Man?
Yes.
Now we do, because we divided by a negative or a -1. And what is a +9 divided by a negative?
-9.
And that is our final answer. And again, just make a little number line. Mark the only number that really you should be interested in this case. Open or closed? Closed. Shading to the left. And you might wonder, why does he want to go over number 4? And well, if you haven't figured it out yet, you will soon. So problem number 4. What's the problem with problem number 4? Variables on the wrong side, and we don't have any control over it. Like I was lecturing Rowdy about, like, this isn't where I can say, oh, let's subtract this and it's kind of, the problem is planted right on our plate this way. And so I don't feel like I have a lot of say in this, right? So let's just do our thing and we'll solve this. We'll cross this bridge when we get there. What do we have to do math-wise? Add 13. Because, I mean, the mission has been, since I met you guys 5 weeks ago, get the variable by itself. It continues to be the mission. What's that? So I'm going to add 13 to both sides. And I'm just, as I've been preaching this all year, I'm just going to bring stuff straight down and vertically in a line. I'm going to bring the V straight down. I'm going to bring the Pac-Man straight down. I'm going to bring my math answer straight down. And why does this answer suck?
So would we
Because
just
it's
switch it?
backwards, and there's some decent percentage of people, young people, old people, whatever, who would make the graph backwards. And as I've stated, that's just not going to work for me. So read this to me backwards. What does it say? What does that say backwards? V is actually greater than or equal to 20. So we switched the sign. I'm going to put that in air quotes. We switched the sign, but it's not a mathematical switch like dividing by a negative would be. It's just saying we all agree with this. If 2 is less than 10, which is true, then I should be within my rights to just say it backwards. So 10 is bigger than 2. That's all it is. This answer in the red box is good, yellow egg, dog water. Now let's graph it. Make a little number line. Zoop. Mark your only give a hoot point. Open or closed?
Close.
Closed for the 4th straight time. Which way do we shade?
Left.
To the right, because it says is greater than. Again, put your big chunker arrowhead on there and you're good to go. So you have 7 minutes left today. Tomorrow will probably just be a work day, but it will obviously not just be this assignment. There'll be more. So you have 7 minutes left. Let's use them wisely, see how much we can get done. Okay.